Have you ever wondered what shapes a planet's climate? It's not just about distance from the sun or its atmosphere. From geological forces to cosmic influences, countless factors come into play. Did you know even a planet's tilt or volcanic activity can make or break its ability to sustain life? Join us as we dive into 10 surprising factors shaping a planet's climate and explore what this means for Earth and beyond. Planetary tilt dictates seasons and weather patterns. The angle at which a planet tilts on its axis plays a massive role in determining its climate and seasons. For Earth, this tilt creates the familiar cycle of spring, summer, fall, and winter. Without it, our planet would either experience constant, extreme heat or relentless cold. That axial tilt ensures that different regions receive varying amounts of sunlight throughout the year. Interestingly, not all planets have a tilt as stable as Earth's. Uranus, for instance, is tilted almost entirely on its side, leading to bizarre seasons where one pole faces the sun for decades. Meanwhile, planets like Venus, with an almost upright position, barely have seasons at all. The tilt doesn't just impact the weather, it affects ocean currents, wind patterns, and even biodiversity by creating diverse habitats. What's more fascinating is how this tilt changes over millions of years due to gravitational interactions with other celestial bodies. These shifts, known as Milankovitch cycles, have caused Earth's ice ages in the past. Such cycles remind us that even a planet's slow wobble can determine its ability to sustain life. By studying axial tilts, we gain a clearer understanding of how planets adapt to solar radiation. It's a constant dance between balance and extremes, where even a small tilt can rewrite the rules of climate and habitability. Volcanic activity creates atmospheric chaos. Volcanoes are much more than dramatic eruptions, they're powerful climate influencers. On Earth, volcanic eruptions release gases like carbon dioxide and sulfur dioxide, which can either warm or cool the planet. For example, Mount Pinatubo's eruption in 1991 released enough sulfur dioxide to temporarily cool Earth's climate by reflecting sunlight back into space. But it's not just cooling effects. Over millions of years, sustained volcanic activity has been a key source of greenhouse gases, driving periods of global warming. Venus provides a dramatic example. Its thick, carbon dioxide-heavy atmosphere may be the result of past volcanic eruptions on an enormous scale, creating its current runaway greenhouse effect. Volcanoes can also shape a planet's surface and atmosphere over geological timescales. On Mars, ancient volcanic eruptions may have helped sustain a thicker atmosphere, making the planet more habitable in its early history. Similarly, Jupiter's moon Io is the most volcanically active body in the solar system, and its constant eruptions continuously reshape its surface and atmosphere. Volcanism reminds us that planetary climates are often in flux. Whether it's Earth's temporary cooling after an eruption, or Venus's long-term greenhouse effect, volcanoes are a powerful force shaping climate in dramatic and unexpected ways. Oceans act as climate regulators. Oceans are the unsung heroes of planetary climate systems. They absorb vast amounts of heat from the sun and distribute it around the globe through currents, creating a more balanced climate. Without oceans, Earth would experience extreme temperature swings, making it far less hospitable. Take the Gulf Stream, for example. This powerful ocean current transports warm water from the tropics to the North Atlantic, moderating temperatures across Europe. But it's not just heat distribution. Oceans also act as massive carbon sinks, absorbing around a quarter of all human-produced carbon dioxide. This process helps slow global warming but has its limits, as rising CO2 levels lead to ocean acidification. On other planets, oceans, or the lack thereof, play an equally pivotal role. Early Mars is believed to have had vast oceans, which may have contributed to a more stable, Earth-like climate before the planet lost its atmosphere. Similarly, scientists speculate about subsurface oceans on icy moons like Europa and Enceladus, where liquid water could interact with rocky layers to create a stable climate conducive to life. Oceans show us how interconnected planetary systems are. They regulate temperatures, cycle gases, and even influence weather patterns. Without them, planets lose their capacity to moderate extreme climates, leaving them vulnerable to rapid and often catastrophic changes. The role of magnetic fields in climate stability. Magnetic fields are often overlooked when considering a planet's climate, but they play a crucial protective role. Earth's magnetic field acts like a shield, deflecting harmful solar wind and cosmic radiation. Without it, these charged particles would strip away the atmosphere, making the planet vulnerable to extreme temperature swings and surface radiation. Mars provides a cautionary tale. The red planet once had a magnetic field but lost it around 4 billion years ago. Without that protection, the solar wind gradually eroded Mars's atmosphere, leaving it with a thin, fragile layer that can no longer retain heat. This loss transformed Mars from a potentially warm, wet world into the cold desert we see today. Even on planets with strong atmospheres, magnetic fields are vital. Jupiter and Saturn's massive fields protect their moons like Europa and Titan from intense radiation. This shielding effect creates environments where life might have a chance to survive beneath the surface. Magnetic fields are more than just invisible shields, they're climate stabilizers. By preserving atmospheres and deflecting harmful radiation, they ensure that planets can sustain the delicate balance needed for stable weather and, potentially, life itself. The role of plate tectonics. Plate tectonics do more than shape a planet's surface, they are a major player in shaping its climate. When tectonic plates move, they create mountains, volcanoes, and even entire continents, all of which influence weather patterns and global temperatures. For example, mountains can block airflow, causing rain on one side and deserts on the other. Think of the Himalayas and the dry Tibetan Plateau behind them. Volcanic activity releases gases like carbon dioxide into the atmosphere, contributing to a planet's greenhouse effect. But here's the twist. This same process also helps regulate the climate over long periods. The carbon cycle, driven by tectonic activity, ensures carbon dioxide gets recycled between the atmosphere and the Earth's crust. Without this, a planet's climate could spiral out of control, either freezing solid or overheating like Venus. Plate tectonics also plays a role in ocean circulation. Shifting continents can change the flow of ocean currents, impacting how heat is distributed around the planet. Imagine the difference between warm, tropical oceans and icy polar waters. They set the stage for global weather systems. Not all planets have active tectonics, and that's a big deal. A stagnant planet, like Mars, lacks the tectonic processes needed to recycle carbon and maintain a stable climate. So, tectonics aren't just about shaping land, they're about shaping the future of a planet's habitability. The impact of a planet's tilt. A planet's axial tilt is like the stage manager for its seasons. Earth, for example, has a tilt of about 23.5 degrees, which gives us the familiar cycle of spring, summer, fall, and winter. But not all planets are so lucky. Take Uranus, which is tilted on its side at nearly 98 degrees. This extreme tilt leads to wild seasonal changes, with one pole facing the sun for half a year, while the other remains in darkness. Without a tilt, a planet could have no seasons at all, resulting in monotonous climates with perpetual cold at the poles and unrelenting heat at the equator. On the flip side, an extreme tilt could make a planet uninhabitable by creating temperature swings so severe that life couldn't adapt. The tilt can also change over time due to gravitational interactions with moons or nearby planets. Earth's tilt is stabilized by the moon, but if that weren't the case, our seasons could be far more chaotic. These wobbles, known as axial precession, can even lead to long-term climate cycles like the ice ages. In short, axial tilt is a subtle but essential factor in creating the diversity of climates that can make a planet habitable or completely unlivable. The influence of a star's luminosity. A star's brightness isn't just about lighting up the sky, it's a key factor in shaping the climate of the planets orbiting it. Our sun provides a steady source of heat and energy, but stars can vary dramatically in luminosity over time. Young stars, for instance, tend to be more active, blasting their planets with intense solar radiation and stellar flares. Even small changes in luminosity can have a big impact. During the sun's 11-year solar cycle, its energy output fluctuates slightly, causing subtle changes in Earth's climate. Over longer timescales, the sun's luminosity has increased by about 30% since the solar system formed. That's a big deal when you think about the conditions that allowed life to evolve on Earth. Other stars, like red dwarfs, can have wildly different effects. These cooler stars emit less visible light, but produce more infrared radiation, which could create a greenhouse effect on nearby planets. Meanwhile, massive blue stars are so luminous that they can strip away a planet's atmosphere entirely. The balance between a planet's distance from its star and the star's luminosity is critical. It determines whether a planet ends up like Earth, Venus, or Mars, or something entirely different. The power of magnetic fields. Magnetic fields are an invisible shield that can make or break a planet's climate. They protect a planet's atmosphere from being stripped away by solar wind, the stream of charged particles constantly flowing from a star. Earth's magnetic field is a hero in this story, keeping our air breathable and our climate stable. Without a magnetic field, a planet is vulnerable. Look at Mars. It once had a thick atmosphere and possibly even liquid water on its surface. But when its magnetic field disappeared, solar winds stripped most of its atmosphere away, turning it into the barren desert we see today. Magnetic fields can also influence climate indirectly. They guide charged particles toward a planet's poles, creating stunning auroras but also helping to regulate atmospheric chemistry. This interaction can affect everything from ozone layers to cloud formation, playing a role in global temperatures. Not every planet gets to have a magnetic field. It depends on having a molten metallic core and enough rotation to generate one. This makes magnetic fields another crucial, yet often overlooked factor in determining a planet's long-term habitability. The role of atmospheric composition. The makeup of a planet's atmosphere is like the control panel for its climate. Gases like carbon dioxide, methane, and water vapor are powerful greenhouse gases, trapping heat and regulating surface temperatures. Without them, Earth would be a frozen rock. But too much of these gases can turn a planet into an inferno, as Venus demonstrates. Atmospheres also influence how much sunlight is reflected in space. Earth's clouds, for instance, play a dual role. They can cool the planet by reflecting sunlight, or warm it by trapping heat. Meanwhile, the thick sulfuric acid clouds of Venus act like a thermal blanket, making it the hottest planet in the solar system, despite being farther from the sun than Mercury. Different gases absorb and emit heat at different rates. Methane, for example, is far more effective at trapping heat than carbon dioxide, even though it's in smaller amounts. These small differences in composition can greatly affect a planet's climate. Even minor atmospheric composition changes can lead to major climate shifts. Ice ages, warming periods, and other climate events on Earth are often linked to changes in greenhouse gas levels, proving just how sensitive a planet's climate system can be. The surprising effects of orbital eccentricity. A planet's orbit isn't always a perfect circle. When an orbit is more elliptical, the distance between the planet and its star can vary significantly, leading to dramatic changes in climate. For Earth, our slightly elliptical orbit causes mild seasonal variations. But for planets with more eccentric orbits, the effects can be extreme. Imagine a planet that spends part of its year close to its star, basking in intense heat, and then swings far away, plunging into a deep freeze. These temperature swings can make it nearly impossible for life to thrive. Some exoplanets even experience snowball phases where they freeze entirely before warming back up. Orbital eccentricity can also impact the length and intensity of seasons. A planet with a highly elliptical orbit might have one hemisphere experience scorching summers and the other endure harsh winters, creating a wildly unbalanced climate. Gravitational interactions with other planets or moons can influence a planet's orbit over time, making orbital eccentricity a dynamic factor in climate evolution. It's a reminder that even the path a planet takes around its star can shape its destiny. And there you have it. 10 surprising factors that shape a planet's climate, from magnetic fields to orbital eccentricity. These elements remind us just how complex and interconnected a planet's environment truly is. If you enjoyed this deep dive into planetary science, don't forget to like, share, and subscribe to InnoVision Tech. Hit the bell icon to stay updated on our latest videos. Until next time, keep exploring the wonders of the universe with us.